In the last lecture, we learned that whenever a state in a component changes, that component is re-executed, and with that, all its child components are also re-executed, even though nothing is changing in the child component. For example, here we have this demo component, and inside this demo component, we are also using this span component. And to this span component, we are passing this value 10 using prop. So if I go to this span component, here we are using that value. Now, when the state in this demo component will change, that means when the value of this count variable will change, this demo component will be re-executed. And with that, this span component will be also re-executed because here we are using that span component. But in the span component, nothing is changing. Here, the value of this props.children is always going to be 10 because that's what we are passing here. Now, this will certainly cause some performance for React application. That's because here we have unnecessary function execution and virtual and real DOM comparison ongoing. Although React is highly optimized for these function executions and DOM comparison, so in most of the apps, especially simple apps like the one which we are using, here it is not going to matter. But in larger React applications, where you will have a big nested component tree, you might want to optimize it and prevent unnecessary evaluation of child component functions whenever nothing is changing in there. So you as a developer can tell React that it should only re-execute a component, in our case, this span component, only whenever the props inside this span component changes. If the props inside this span component, so in our case, if this props.children value does not change, in that case, we don't want this span component to be re-evaluated. We don't want it to be re-executed. Okay, so what we want is, we don't want this span component to be re-executed if this props.children here does not change. And not only the children property of this props, if none of the property of this props object is changing, in that case, we don't want this span component function to be re-executed. For that, all we have to do is, when exporting this component, we have to wrap this component within React.memo. So now if I save the changes and if you go to the web page, and here, if I open developer console, let's clear everything here. So when I click on this plus button, the state inside this demo component will change. And when the state inside this demo component will change, by default, it will also execute this span component. But now, since we are exporting this span component using this React.memo method, if this props does not change inside this span component, this span component will not be re-executed. Let's see that. So here when I click on this plus button, you will notice that the demo component has been executed, but the span component here has not been executed. If I click on this plus button again the demo component has been executed, but not the span component. But if I go to demo component here, and instead of setting this value 10, if I use this count variable, in that case, inside this span component, whenever the state here in the demo component will change, that means whenever the value of this count variable will change, we are passing that value of that count variable to this span component. So in that case, here, this props.children value will also change. So in that case, this span component will be executed. Let's see that. Let's go back to our web page. Let me clear the console here. Let's also refresh the page. So now if I click on this plus button, you will see that both demo component and span component has been executed. So here, this span component is only getting executed when the value of this props is changing. Now remember that this React.memo will only work with functional components. For class-based components, it is not going to work. Now, we will learn about class-based components in our coming lectures of this course, and there we will take a closer look at how we can optimize class-based components. Okay, so this React.memo, this method tells React for this component, which it is getting as its argument, React should look at the props this component gets and check the value of those props and compare it to the previous value of those props. That means if the new props value is different from the previous props value, then only the component should be re-executed and re-evaluated. So if the parent component changed, but the prop value of that component did not change, component execution will be skipped. Okay, so here we are optimizing our React code to avoid any unnecessary re-rendering. Now you might ask, why aren't we using this React memo on all the components since it allows us to optimize them? That's because this optimization comes at a cost. This React.memo method here tells React that whenever the app component changed, it should go to this span component here and compare the new props value in this component to its previous props values. So therefore, here React needs to do two things. It needs to store the previous props value, and it also needs to make that comparison. And that also has its own performance cost. And therefore, using this React memo depends greatly on the component to which you are applying it. Because here, using this React.memo, we are trading the cost of re-evaluating the component for the performance cost of comparing the props. Now, it's impossible to say which will cost higher performance because it depends on the number of props you have and on the complexity of your component, and also the number of child components your component has. So the next question is when you should use this React.memo and when you should not use this React.memo. So if you have a component where you know that its props value is going to change pretty much every time, there using this React.memo does not make any sense, because if the component props is going to change anyways, then you can save performance cost by not using React.memo and avoiding the extra props comparison. Also, for the small apps where there are not a huge component tree, there we can avoid using React.memo. But with large apps where we have huge component tree structure, there we can use React.memo to avoid any unnecessary reevaluation of components. But just remember that you don't wrap every component with React.memo. Instead, you might want to pick up some key components in your component tree where you know that the props value might not change that often, and there you can apply this React.memo. Alright, so this is about React.memo. We use React.memo to avoid unnecessary reevaluation of a component if in that component the props value is not changing. Now this React.memo also has an exception. Let's understand that. So currently to this props.children, we are passing this value count. Now let me pass 10 here. So here we are passing a number. So whenever the state in this demo component will change, this demo component will be re-executed. But this span component will not be re-executed because here for this props.children, we are always going to receive the same value. We are going to receive this value 10, right? So since the props value inside this span component will not change, and since we are exporting it using this React.memo, this span component will not get re-evaluated if this props.children does not change. So if I go to the web page, let's clear everything here. Let's also refresh the page. So you will notice that when I click on this plus button, demo component has been executed, but span component has not been executed. If I click on this plus button again the demo component has been executed, but the span component has not been executed. That's because in the span component, this props.children is always 10. It is not changing. But now, instead of passing this number 10, if I pass an array here, let's say this array has two elements, 10 and 20. And here, let's say we want to print the first element of that array. So here, let's use this index. Okay, let's save the changes. Let's go to the web page and let's see what happens now. Let me reload the page. Let's clear everything here. So when I click on this plus button, now you will notice that both demo component has been executed and span component has also been executed. But here, this props.children is going to receive this array. And the first element of this array is always going to be this value 10. So in the span component, this props.children of 0 is always going to be 10. And that's why when I click on this plus button, you will see that this value is not changing. But for some reason, this span component is still getting executed. But if you remember, we have returned this span component by wrapping it within React.memo. So since the value of this props.children is not changing, it should not re-evaluate this span component. But here it is re-evaluating that span component. And the reason behind this is this array is of reference type, but this number 10, it is of value type. So in case of value type, for example, this number, This number is of primitive type, and primitive types are value types. So in case of value type, when we are passing this number 10 to this span component, to this props.children, that value 10 will be assigned. So here in the demo component, when the state will change, this demo component will be re-executed, and with that, this value 10 will also get recreated. It will be recreated somewhere in the memory. But when we are passing this value 10, the value stored in that memory will be passed to this props.children. So here the value is going to be same. But when we are specifying an array, this array is of reference type. So when the state in this demo component will change, this demo component will be re-executed, and with that, this array will also get recreated. And when we are passing this array to this span component, instead of passing this array, a reference to this array will be passed to this span component. Okay, so when this array will be recreated, the reference might change. The memory address where this array is getting created, that memory address might change. And we are passing that memory address, that reference to this props.children. Okay, that's why in case of reference type, since the reference can change, this props.children can have a different value, a different reference. But in case of value type, the value will always remain same. Even though this value 10 will be recreated in the memory, but the value will remain same. And in case of value type, we are passing the value. We are not passing the memory address. But in case of reference type, we are passing the memory address. We are passing a reference, and that reference might change. So let's go ahead and let's see a use case which actually uses this concept. So what I'm going to do is, inside this UI folder, I'm going to create a new folder. I will call it button, and inside this button folder, I'm going to create a new component. I'll call it button.js. Here, let's first go ahead and let's import React object from React library. Then let's go ahead and let's create a function component. Let's call it button. And let's also go ahead and let's export this button component as default. Now, from within this button component, I want to return a button element, and within these opening and closing button element, let's use props.children. So for that, let's say this button is going to receive a props, and within these curly braces, let's say props.children. Then here, let's say we also want to listen to click event. So whenever this button is clicked, we want to execute a function. So let's call that function maybe click handler. Okay, and we are going to receive this click handler on this props. Now let's go ahead and let's use this button component in our demo component. So here, instead of using this button element, let's go ahead and let's use our button component. And in order to use this button component, we also need to import it from this file. Let's also provide a closing button element. And within this, let's specify this minus. So here in the button component, this props.children will be replaced with this minus. Let's do the same thing in place of this button element. And here, let's say plus. Now this button component is also expecting this click handler props. So let's go ahead and let's specify that props by adding an attribute here. So when this minus button is clicked, in that case, we want to pass this decrement handler function to this click handler. So in that case, this decrement handler will be assigned to this onClick event listener. And in case of plus button, again, let's specify this click handler attribute. And to this, we want to assign this increment handler. Let's also go ahead and inside this button folder, let's create a new file, and let's call this file button.css. And from this demo.css, I'm going to copy this counter button class, and let's paste it inside this button.css. And in the button component, let's also go ahead and import that CSS file. And on this button element, let's go ahead and let's add a class name. And to that, let's assign this class, this counter button class. All right, let's go to the web page. So our application is looking as earlier. Now, what I also want is in this button component, I want to log a message. Let's say button executed. Then let's also wrap this button component within React.memo. With this, let's save the changes. So here, let's close this CSS file. Let's also close this CSS file. So in the demo component, whenever this state will change, so whenever the value of this count variable will change, this demo component will be re-executed, right? But when this demo component will be re-executed, this span component should not be re-executed, because in the span component, here we are passing this value 10. So in the span component, this props.children will always remain 10. Its value will not change. In the same way, this button component should also not be re-executed. Why? Because if I go to this button component, in this button component also nothing is going to change. This props.children will always remain either plus or minus based on where we are calling it. Okay, so either it will be minus or it will be plus. This value will not change. And then this function is also not going to change. Its definition will always remain same. And since we are exporting this button component using React.memo, and since in this button component nothing is going to change, the props is not going to change, it should not be re-evaluated, right? Let's see if that's the case. Let's save the changes here. Let's go to the web page. Let me clear the console. Let me refresh the page. So initially, for the first time, the demo component was also executed. The button component got executed. The span component got executed. And then this button component got executed. So this button component has been executed twice because in this demo component, we are using this button component twice. All right. Now, let me clear the console. So now when I click on this plus button and when the state in the demo component will change, only the demo component should be executed. The span component and the button component should not be executed. Right. Let's see if that's the case. If I click on this plus button, you will see that the demo component has been executed. The span component did not get executed, so that is an expected behavior. But this button component has been executed, and it has been executed twice. Again, because we are using this button component 2 times in this demo component. But it should not have been executed because if you remember, we are exporting this button component using React.memo, and we saw that inside this button component, this props value is not going to change. But why this button component is getting executed here is because here to this click handler, we are passing a function. Okay, so for the first button to this click handler, we are passing this decrement handler function. And for the second button to this click handler, we are passing this increment handler function. Now, a function in JavaScript is also an object. It is of reference type. So even though the definition of this function is not going to change, but when the state in this demo component will change, that means when this count variable will change, this demo component will be re-executed. And when this demo component will be re-executed, this function and this function will be recreated. And since these are of reference type, to this click handler props, that means to this click handler, a reference will be assigned. And as I mentioned earlier, a reference might change. So let's say when this demo component was rendered initially for the first time, this function is at address 0x12345. But when the state changed here inside this demo component, and when this demo component was re-executed, again this function was created. But this time the memory address is different. So this time it was created at some different memory address, maybe 34567. So this is the value which will be passed to this click handler. That means this props.click handler will change from 0x12345 to 0x34567. And since the props value changed there, that's why this button component was re-executed. All right. So basically, to understand this concept, you should have at least a basic knowledge of what is value type and what is reference type and how value type and reference type works. Now, in the description of this lecture, I will share the links for learning the value type and reference type and also for pass by value and pass by reference. So you can watch that lecture and then this concept might be clear to you. So this is one exception with React.memo. When working with reference type, this React.memo might not work as expected. But with value types, it is guaranteed to work as expected. Now we can overcome this problem and let's see how in the next lecture.